Good afternoon, everyone. Thanks for joining us. We realize that we're in between Jewel and Shaquille, so thanks for making it. My name is Pavel Despot. I am a solution engineer. I'm based out of Cambridge, our headquarters, and I work mostly with what we call at Akamai high-tech customers. So think of folks that are writing their own applications, writing their own services, and then coming to Akamai for security, performance, all the stuff that you've heard about over the last few days. Today, though, I wanted to take a little bit of time and talk to you folks about load balancing. It's not always the sexiest topic, but we've seen a lot of effort around automation and how we can use the auto-scaling and some of these features in our compute and how we feed that back in, right? Because if we can't load balance across, it doesn't really matter that that exists. So before we start, just to define our terms of what load balancing is, because it is a very broad topic, and we can talk about layer 7, we can talk about layer 3 and just doing DNS load balancing, but I think for the purposes of this, let's just keep it really simple and broad and define our load balancing as just simply routing requests from a client. Right? That client might be an end user going to a web page. It might be even an Akamai server coming to an origin. Right? But ultimately, we're just talking about routing requests in order to maximize our availability. Right? We want to route the request to a compute instance that is available. We also want to take into account the load. Right? We don't want to just send everything to one instance and overload that. Increasingly, though, we also want to take into account performance. I may have 2 compute instances across the country or across the world. How do I decide where to send it to? Right? How do I decide where it's the best place to service that request? It could be, obviously, based on cost or increasingly data sovereignty requirements. If anybody's had to deal with GDPR or those kinds of things, you know the importance of where you actually route these requests and where the compute's handled and where any data persists. So to that end, what we're going to talk about today is briefly just why now? Why are we talking about load balancing? It seems to be something that we've really solved. But in fact, as we look and migrate to newer architectures, the load balancing problem manifests itself in really new and different ways. So we'll look at what I mean by that architecture and those architectural changes, as well as some of the challenges that come with, again, this new architecture, and how we can meet those challenges with automation. And then we'll end with a working demo and give you folks some questions, some time to ask questions about how we did it, why we did it, and so forth. So like I said, load balancing isn't really an issue. Right? We've got this pretty well solved. And what we've been mostly doing today is when we need to deploy an application, right, we stand up our application instance, right? Maybe some sort of LAMP stack, right, Linux, Apache, MySQL, PHP, or whatever your technology of choice is. And you might install it on-prem. You might go to AWS or Azure or IBM Cloud or Rackspace, or the list goes on, and install a VM or a container cluster. And there you go. You've got your application. You put all your layers on it, and it lives in this VM. And then when users need to access it, what happens? Right? You have a DNS name. Users all over the world go to that cluster and make the request. Not really exciting, right? Not, like I said, it's largely what we've been doing. And the only one note I'd make here is, in this case, I have users, but just remember, these could just as easily be an Akamai Edge server, right? Depending on if you've got a CDN or Kona or anything like that in front. For the moment, for the purposes of this discussion, that's largely irrelevant, so I'll just skip that. It could be there, it could be not. This could be users or Edge servers. Doesn't really matter. So now, as our users grow, what happened? Well, we'd usually vertically scale, right? Especially if I managed to deploy this in some compute. It's pretty easy. I'll go and throw some more CPU or throw a bigger instance at it, and I can handle more traffic. I can also, if I really need to, stand up a second instance, right? Usually in the same data center, image it, again, especially if you're virtualized, which hopefully a lot of us are, It was never really that big of a problem, stand it up, and now it's pretty simple. Maybe we even throw a cold or warm DR instance somewhere. And largely, that's how we deliver our application. Again, whether there was a CDN or something similar in front, mostly these are your origins for those of you that are in Property Manager and familiar, right? What that really meant for us is that load balancing in that world is pretty simple. There's minimal endpoints. In that diagram, we had 2. Right? Maybe you have 3. And there was a backup. So even if you had to do round robin or something more complex, you weren't really saddled with having to deal with a large selection of endpoints. And a lot of those other issues, like data sovereignty and all that, really didn't come up. Additionally, even though we said, yes, this might be somewhere in some virtualized environment, whether it's your own or some cloud environment, that whole approach wasn't really dynamic. Even if I was just going to image and instantiate another VM, for example, it would take some time, right? I'd have to go in, take an image, start up the new one, add it to whatever load balancing I need to do. So ultimately, the idea that this thing is going to pop up a new instance of compute very quickly that I need to put into my rotation to serve all my client requests didn't really matter. It didn't have to be that quick and that automated. And ultimately, it's because those architectures, right, that LAMP stack or even a J2EE architecture, it really wasn't meant to be distributed in multiple places. You'd have a backup and standby or even a cluster just to deal with load. But all these things ultimately meant that a lot of us, and I'm guilty of it too in previous lives, load balancing or adding new instances meant someone went into your DNS and added a new IP address. Or even into your load balancing, it was extremely manual. And that was okay, right? Because we weren't really losing anything with that. And now I will throw in a quick caveat here because this is somewhat architecture-y, and I am by no means suggesting that something like Kubernetes is better than virtualization in a different way. So everyone, please keep your own religions in mind and realize that this is trying to be generic. But the larger point of however you choose to organize your compute and do your deployment is that there are a lot more instances. It's not just I'm going to throw it in DC somewhere. All my compute is potentially in different places, and there are a lot more, there are a lot more endpoints that I don't want to expose to my customers. I don't want to tell my users, well, if you're in Johannesburg, you need to type in southafrica.pavel.com, right? I need to make this completely transparent. Beyond the multiple locations, one of the things that we increasingly see, especially in our customers that are building their own applications, is this whole notion of a monolithic application based on whatever technology stack we may have used isn't really common practice anymore. We're splitting things up into microservices, whether it's a UI component versus an API component, however you divide it up. It just means I have more locations and more services potentially in each location. And lastly, the whole point of having these and the whole point of why we were promised the cloud and all these wonderful things would help is because I can stop and start instances. They're very ephemeral. That was why this was going to be great. If I need compute in a particular region, in a few clicks, I can get it going, and life is truly good and easy. So from that standpoint, it really was, right? You've written your application, you deploy your code, life's pretty good. But it does bring up a few challenges. And specifically, it's the number of endpoints, right? The first bit. Now, if we continue on the path that we used to do, where we're going in and updating DNS with all of these different endpoints, how do we do that? We don't want to just put 50 A records that we return back for a service. The fact that we can rapidly provision things also adds a wrinkle, because now, having Pavel just go in to your DNS server and update your registry or update the records, that doesn't really work because In this model, things can be spun up and torn down a lot more quickly. So you'll have somebody just typing constantly, and most likely at some point fat finger something. And especially, the fat finger, we've actually had a few instances that should relate. You can actually cause a lot more problems than you'd think. It's not about just not working. You're actually potentially sending sensitive requests to an origin, to an instance, an IP, that you might not want to be. So that's really and we've seen this in a few customers. That's a real issue with doing things manually, right? They're more error prone, and it's just going to take somebody a longer time to do it. And ultimately, if the compute's there, but you're not routing to it, have you really scaled anything? Right? Yeah, it's there. It's sitting idle. The global, and this isn't really a function of more modern architectures. I'd say it's more a function of just the reality of today in our audiences that are consuming these services. When we have these global audiences, you're a lot more likely to have certain spikes. Now, this is very application dependent. Certain commerce apps, we all know, a sale, that'll trigger a large global user base to send traffic immediately. But regardless, we need to deal dynamically with routing decisions. Not just, hey, I've got these 3 endpoints, I'll go a third, a third, a third. We mentioned data sovereignty. It's an increasing requirement for a lot of applications. We have GDPR out there, but increasingly there are either organizations that want to be proactive and do things in certain countries, like keeping requests and data there. So we need to start considering when we're making load balancing and termination decisions we need to consider these things. And lastly, this is Akamai after all. Performance is a little bit of our thing. So can we use load balancing to actually improve end user response time of our application? This problem isn't completely new. People have taken swings at this before. And a common way to do it is this model. So think of DNS Load Balancer as some arbitrary service. This may be something you host. It may just be a simple bind service where you're entering a few IPs. It could be some cloud service. Arbitrarily speaking, you put your DNS in there, and then what you have is in each location, you have some sort of routing engine. Could be Nginx. A lot of folks use HA proxy locally. And that lets the outside world abstract away what you're doing behind that load balancer. You can add and remove instances, so that horrible vertical scaling that we saw in the previous model, right? A lot easier when you're doing it this way. When we look at this way, though, there's still some room for improvement, though. For example, we never really dealt with, we just said a few moments ago that a big problem was just the number of endpoints of different types that we have to deal with. This approach, the lack of automation in this, or the lack of, we're not actually dealing with the problem of having too many endpoints. In fact, we've actually kind of added a little bit of complexity and an additional problem here, because now consider a pair of HA proxies that are fronting your local cluster. We now have to manage the load balancer itself as well. So we have to worry about that scaling as well. We have to worry about that updating. And what we find is that among different providers, if you use some homegrown different cloud service providers, if you use some of the homegrown functionality that takes a swing at making this a little bit easier and more automated, then you run into a problem of a heterogeneous approach depending on which service provider you use, or if you have something on-prem. So we're continuing, if we do this approach, we continue to make things different and have our whole workflow be largely dependent on where my compute is, what service provider, how things work. And the whole point of this was we abstract this away. On the DNS load balancing side, depending what service you use, you want to be able to not just do that simple round robin. We want to take into consideration load balancing, the current load on the system. Like we said, global audiences, we can have a big spike very quickly. So we don't necessarily just want to say, this geo goes here, or you get 33% and you get 33%. And lastly, with this particular kind of approach is we don't really have any feedback. We don't know, or more correctly, the DNS load balancer has no idea of what's going on. Is the endpoint alive? Is it busy? Does it still exist? So we've really got this disjointed front end that's controlling the traffic to all of our endpoints. What we're going to go through today, and after a couple more slides, I promise we'll get to an actual working demo so you can see some code and some machines. What we'll see is this kind of approach. So think of your users. Again, replace all these little folks, orange icon of people here with edge servers potentially, clients. Right? Doesn't really matter. And this, of course, is, we're specifically talking about, in this case, what Akamai calls global traffic management, our DNS load balancing solution. So what we want to do first when somebody goes to an application, to an endpoint, is identify what are my potential targets, right? What compute do I have available and where, and what is okay, where is it okay for me to route these requests? Again, think of geo type of rules. Think of routing based on IP address or resolver. So you can do things like split DNS. Instead of just kind of going round robin, add some more intelligence in there so that we can make decisions in order to deal with things like data sovereignty and GDPR and so forth. On top of that, though, before we make any decisions on where we should go, let's see if all these endpoints that we know of are actually up and running and healthy. Otherwise, we probably shouldn't route to them. And the way we have to do that is have some sort of health check. Have some sort of way to determine alive or not. And I think oftentimes, especially with health checks, people think that a single, hey, I checked this URL 30 seconds ago and it returned to 200, so I'm fine. But the thing to consider is not just, do I have a health check? But how am I doing my health check? Because, remember, it's not just an agent checking your application. It's your agent checking your application over the internet. So it's not really difficult to imagine that your agent can be perfectly healthy, your endpoint can be up, that particular query just, a request failed because of some internet connectivity options. So if you were just doing a health check from one or two locations, and you have this very binary logic that says, oh, this failed once, or this failed 3 times, or this failed X amount of times, and then I'll consider it dead, you're potentially failing over when you shouldn't be, right? Because you should only be failing over if the downtime is real and affecting users. But you can actually even be failing back when you don't need to. So the idea around GTM's approach is multiple health check agents from multiple locations with a configurable heuristic to determine at what level I want to deem something is down. And for down, we'll say, don't route to it anymore. Now, of course, once we have that information, now we can layer that on top of our routing logic and immediately disqualify any target that hasn't met that criteria of liveness. So we've thrown in metrics here. This is the first part of our automation discussion. And in here, we can just think of whatever, again, very generic, we can just think of whichever logging system you personally like to use. Datadog's downstairs if you want to talk to them, New Relic, you roll your own Nagios if anyone has been doing this for that long. But ultimately, right, you're probably, hopefully, monitoring your endpoints somehow. And it's that monitoring that we would generally use to say, hey, I need to add another instance. Now, when we add that instance, right, we said before that adding a compute is great. We can automate that. It's really easy. But at this point, that still hasn't made it into the rotation. We're not sending those 2 new instances in each of those locations any traffic at this point in the diagram anyway. In order to do that, what we can do is simply have that logging system, whatever it is, call an API to GTM. Done. And that API specifically, think of your entire routing logic as represented by a JSON object. Update that JSON object and push it to GTM. That's the routing logic that will take place. Take something out, update your JSON, GTM takes it out. And the idea here and how we deal with how we deal with some of those problems that we said other approaches don't help or don't address is, well, now this is automatic. I'm not having anyone go in and fat finger an IP address at 2 in the morning when something failed over. I'm not having anybody go in and keep track of what's alive when I have to take something out. And I'm certainly not having to wait for anything to update, because as soon as you've instantiated your new instance, you make the API call, and there you go. We've even had people actually throw their whole GTM config in Git. So we talked about these, but just to really summarize why you'd go through this effort. We've removed, with this approach, we've eliminated the need of those local HA proxies. Right? Expose your endpoint directly. And certainly, I'm not suggesting that for those of you Kona customers and using SiteShield that you abandon it. Certainly not. But from simply a routing perspective, expose those endpoints directly. Don't worry about managing your HA proxy or your ALB and waiting for that to auto-scale too. Right? That's just extra layers that adds latency. And remember, we are still after performance. That adds extra layers, adds extra maintenance, and is extra compute cost. And when you remove those, that does give you now a more consistent approach. Because regardless of what CSP you're using, all these all these endpoints are just that. They're endpoints. So an IP on port 443 is really no different if you use Azure versus Rackspace versus AWS. The automation piece, obviously, as we talked about, now things are going to scale up and scale down quickly. So as soon as that instance is up, you kick things off. Whether somebody's awake at 2 in the morning watching this or not really doesn't matter. The goal of that, of course, is to improve your availability and resiliency. And as we mentioned, of course, all those users, they could be edge servers as well. So for those of you who are familiar with Property Manager, all of this applies with this being your origin hostname. So let's have a look. We actually have a demo of this, and for the sake of just explaining everything, today the role of Cluster 1 will be played by an AWS instance that I have, and the role of Cluster 2 I have running over in Azure. The app itself is real. So this is our Azure machine. Very nice. Ubuntu prompt. And the application that I'm load balancing is a timed out putty session. And the application that I'm load balancing is a simple HTTP API that generates prime numbers. Feel free to use it. You'll see the URL in a second. The reason I chose it is because there was a NumPy library that was really easy to use, and generating prime numbers happens to be a computationally expensive process that is going to help in 2 seconds when I throw a ton of traffic at this. So, right, there it is. Not crazy exciting. What is more exciting, though, is the monitoring piece. So, as that visible? Yeah. As I mentioned before, some monitoring. I happen to use New Relic in here, but insert favorite platform. And the important aspect to this is the monitoring. So what I've got, and for just make sure there's no rabbit out of the hat, this is indeed our Azure instance, US West. This is our EC2 instance. And you'll notice we have one guy stopped here, which we will see start up in just a moment. So for the sake of not making you guys wait while this ramps up, I'm going to simulate right now traffic hitting this, this application. So I happen to be using Cloud Test. It's a different product that Akamai offers. It's used to load test APIs and applications and whatnot. Not the topic of this. Short story and what's relevant for this, I'm going to throw traffic at this application right now. So while we do that, what we can look at is that GTM configuration. So right here, we've got our host name, right? And what we can actually see is if I go to, that's the app. And what's happening is, for those of you that are familiar with Akamai, is that this host name is simply CNAMEd to that GTM property. And that's how GTM works. Just like you're CNAMing over to Akamai Edge nodes. And we can see that it's CNAMEd to edge2019.paveldespot.net.akadns.net. Just like Edge Key is our secure hostname that you CNAME to, Edge Suite's the non-secure, this is just the DNS hostname. And for me, I happen to resolve to this guy. When I look at my GTM setup, well, it's not really that surprising that that's what I resolve to. And again, for just the sake of pretty graphs, I gave these different percentage goals. Your setup may vary. But right now, the setup is relatively simple. I've got a host name that's CNAMEd to a GTM property. And that GTM property will, based on these rules, distribute traffic across these two. What we're going to see when I click back on my monitoring and zoom into a 5-minute window is, in just a moment, you will see this alert. And I've set, in my case, for 50% CPU. Again, your exact numbers will vary depending on if you want fault tolerance or high availability. We can happily chat about the difference between the two later. But ultimately, what we've got is in our alerts, I've simply set up an alert that says, watch for high CPU. What you monitor may vary. But again, for this purpose, I've just said, hey, when there is a high CPU for at least a minute, I want you to send a notification. That notification happens to be, in my implementation, I've asked it to send a webhook. And that webhook is going to a Lambda function that I wrote. That Lambda function, I use Lambda just because I had it kicking around, right? Not really important where it goes to. What is important is that that Lambda function, in which I can show everyone, has taken our, I happen to use our Ruby library to do our API authentication. And what that allows us to do, is start sending JSON bodies representing our GTM load balancing scheme to GTM and back. So in this case, and please, for those of you that code, I am relatively new to Ruby. Excuse any lack of error checking, lack of substantial error checking. But this is really it. All I did was import the edge grid library, like I said, in this case, Ruby. And in here, I've just said, get the config, start a new, append the server, and off you go. So what that's actually doing, if we go back to our infrastructure monitoring, when this loads, we should see a little yellow line indicating an alert. Again, if I go back to 5 minutes. Right? So that is our alert. It makes sense. We said fire the alert when you're over 50%. That one server seems pretty well pinned. So I would expect that alert to fire. And again, this is how just New Relic works. It did. So that means then, two things should have happened if I didn't lie to you. That new instance in EC2 should be started, and it should be in GTM, right? Meaning that when I make requests, it'll route there. And we can have a look. So first thing, I'll click over to our EC2. And you'll remember before we had one running and one stopped. The only reason I had it running instead of instantiating it from an AMI is because I was lazy in my code. That's it. Normally, I probably wouldn't have a stopped instance sitting there, so please don't walk out of here telling people that this guy from Akamai said have a whole bunch of instances just sitting there doing nothing. But if we scroll this guy down, we've got our 2 instances running. So that's great. You know, auto-scaling has been working for a while. That's not really, I didn't show you anything particularly exciting. What the interesting part becomes is now if I just reload this, tense moments. I've got my new IP in there. This means that when I start routing, when I start resolving this, it's going to resolve additionally to that. Oops, wrong window. Right. So now we've got traffic going to both of these systems. And we can actually see that in just a moment. We see the traffic actually duck down as a result, because now I haven't increased my load, right? But I've distributed it across a lot more systems, and we've already picked this new guy up in here with New Relic. It's not really hard to think that the next thing I would do, with this is implement take something out of service. It's the same API call. It's the same flow. It's just, hey, I have now, the conditions abated. I don't need this extra compute. Turn it off. Personally, I would do the order of operations backwards when you're turning stuff down. The health check would catch it, but best practice, for when you're auto-scaling up, instantiate, add to GTM. When you're downscaling, rip it out of GTM, then turn off what you need to turn off. Another instance of this, and I didn't actually add it into the API, but another instance or another use of this is for any work you're doing, any maintenance. It may not be obvious for even those that you may have used GTM, but that button, that's a slider. And if I was doing this through the UI, it disables my target gracefully. Right? As the TTL will expire, when GTM is queried again for that, it's no longer going to hand that out. So you can just watch, again, your log and maintenance system and say, oh, OK, great. I disabled it, and you're done. And disable in the JSON object is a separate enable disable. But same idea, right? You don't just have to look at this as auto-scaling. The idea here is this is traffic management. Whether it's for maintenance, whether it's for scaling, whether it's for, we were talking to somebody today, and they were talking about using this when they detected a security anomaly on the platform, right, on one of their instances. They said, hey, can I just disable it? Well, yeah, you can disable it that way. So I guess my point in saying all that before I wrap up and let folks ask some questions, I wouldn't walk out of this thinking, hey, this is an auto-scaling solution. This is genuinely a way to manage, dare I use the word serverless, your routing, again, as a simple code, as a JSON object. So that was all I had. I am more than happy to take any questions. We didn't talk about layer 7. Maybe a different session for next year if you guys don't throw tomatoes and say this is terrible. Please. I think there's a...
How quickly does it take it out when you disable it? And then how long does it take it when you API pull IPs out? You know, what's the resolution time?
Sure. So right about now for GTM, you're looking at about 5 minutes from when you make the API call of any change. Whether it's an add or remove, enable or disable, it is essentially GTM's current activation time. Much like for those of you that are familiar with the delivery config or the security config when you click activate, it's around 5 minutes for that to propagate at the moment. Yes, exactly. Yeah. Other questions?
Just wondering why you chose GTM and maybe not ALB in your demo?
Because I didn't have enough time for ALB.
Okay.
And I actually think for this, it would be a little tricky to show all the pieces. This one was a little simpler in 40 minutes and my marginal Ruby skills. I would point out, if anyone wants to go home and try this, or something similar, the libraries are on developer.akamai.com. There is a separate section that just has libraries. We've got Node, Ruby, Python, a couple others. Python, heads up for anyone, because Python was my choice. I like Python more than Ruby, but the issue is with Lambda. Our current Python library implementation requires a few libraries that are a pain in the butt to get into Lambda. Right? They're not, I wouldn't call them obscure Python libraries, but they weren't nearly as easy as any of the other libraries. With this, I quite literally used the AWS CLI and just said, create function, here's my vendor package for my gem, done. Python, if you're going to try it, I share this to save some of the heartache that I had. Python, our current implementation, doesn't play too nicely due to some library dependencies.
So we've had a couple discussions internally at our company about the right way to determine a liveness test object for GTM.
Yes.
We've decided that it's important to add some additional logic, like all the way down to the database layer and return 200 there. Do you have any insight into what you think the best practice is for that?
I think it varies a little. I wouldn't say there is a single best way to do it. What I would say, a few kind of guidelines to do it would be, think about how sensitive you are to a failure, first of all. And if it's very, then go into GTM and take your most aggressive, the aggregation score. Go aggressive there. That might result in, call it a false failover. But again, if your application is such that your biggest priority is the ability to service an end user request, then the trade-off of, oh, why did the compute stop here? Oh, it's because this agent just happened to drop a packet or the request didn't work. The other thing I'd say is, as a best practice, really look at failback delay. The failback delay, for those of you that aren't familiar with GTM, is a delay in seconds that tells GTM, hey, I know your liveness test just worked, and that's great, but just give me X seconds before you start handing that IP out. And the reason I suggest using that is the number of times the health check endpoint comes up, and it says, yep, 200 OK. And then your database tier or whatever else is kind of coming up. So we start sending traffic to it, and then it falls back over dead. And then you start the whole cycle over. Definitely use the failback delay. That one I would say is a best practice, right? Unless you have something that magically takes no time to come up. I am being pushed off the stage. I'm more than happy to talk a little more if you like. Please, everyone, rate the session. Tell us if it was helpful. Tell us if it was not. Tell us what you'd like to see, ALB or otherwise. And thank you so much for coming. Enjoy Shack.